Using soldering flux is an important part of any soldering job. In this Buzzle post, we highlight the different types of soldering fluxes, and what each of them is used for. Lead-free solder flux. Under RoHS regulations, excessive use of lead in consumer electronics has been prohibited. Fluxes are not made from lead or any other materials, so all fluxes are basically lead-free. However, there are fluxes which are specially designed for use with lead-free alloys. Soldering is the process of joining two or more metal parts by allowing a filler metal to melt and flow in between them. For the formation of an effective soldering bond, it is essential that the metal surfaces being joined together are clean and free from oxides. Soldering flux is a specially designed material that helps in getting rid of the oxides, and prevents reoxidation from reoccurring until the soldering job is complete. There are several types of fluxes, available in liquid, spray, paste, gel, or pen form. Nowadays, flux is included in the core of the solder wire itself, which is sufficient for most of the smaller soldering applications. In medium to large soldering applications, however, it becomes necessary to apply flux externally. The following is a list of the different types of solder fluxes and their typical applications. Solder flux types. No clean flux. Soldering fluxes are corrosive. As such, if after soldering, the residue is allowed to remain on a printed circuit board (PCB), it may corrode the parts of the board, and even the components. Hence, it becomes necessary that the flux residue is washed off the PCB and components using a cleanser, typically alcohol-based. No clean fluxes are specially designed to have a very mild action. Even if their residue is allowed to remain, it will cause virtually no damage to the board or the parts. Since cleaning after soldering is not required, this type of flux is known as no clean flux. Applications. No clean fluxes are ideal for surface mount PCBs and automated soldering applications. They are also extensively used in wave soldering. Rosin Flux. The primary ingredient in rosin flux is rosin, which is extracted from oleoresin or the sap of pine trees. It comprises an active ingredient in the form of a biotic acid, in addition to a few other natural acids that rosin contains. Most rosin fluxes have activators in them, which make it possible for them to deoxidize and clean the surfaces to be soldered. Depending on the level of activators present, rosin fluxes are further classified into the following subtypes. 1. Non-activated rosin flux. These fluxes are not activated, and as a result, have the mildest deoxidation action. They are best suited for use on those surfaces which are already clean, and have only a minimal amount of oxides present on them. The main advantage of this type of flux is that it doesn't leave behind any residue. Applications. R-type rosin flux is mainly used for soldering copper wires, PCBs, semiconductors, and other hand soldering applications. 2. Rosin mildly activated RMA. RMA fluxes have mild activators, which impart a greater cleaning capacity to them as compared to the R-types. They can be used to clean moderately dirty surfaces. On the downside, however, these tend to leave behind a small amount of residue, which must be cleaned by appropriate flux cleaners to prevent damage to the circuit or the components. Applications. RMA fluxes are ideal for higher lead-containing solders. They are mostly used for general-purpose soldering of PCBs, cables, semiconductors, etc. 3. Rosin-activated RA-type fluxes have the greatest level of activators, which give them the strongest cleaning ability among other rosin fluxes. This makes them best suited for hard-to-clean surfaces on which a lot of oxides are present. On the flip side, these leave behind a lot of residue, which is usually corrosive in nature. Therefore, refluxes are used only in specific applications. Applications. Refluxes are useful for cleaning electrical components made from high lead alloys. Organic acid flux. Organic acid fluxes are also known as water-soluble fluxes, owing to the fact that they dissolve readily in water. They comprise weak organic acids, such as citric acid, stearic acid, etc., which are typically combined with solvents like isopropyl alcohol and water. Organic acid fluxes possess more corrosive power as compared to rosin fluxes, and are quicker at getting rid of the accumulated oxides. These fluxes, however, require cleaning after the soldering takes place, as they can corrode the circuit board and components, and being electrically conductive, may even lead to a short circuit if allowed to remain. Since they are water-soluble, regular water can be used to remove the flux residue while taking care that the components that shouldn't be made wet, and that the entire circuit or assembly is completely dried before power is applied to it. Applications: these can be used in reflow soldering of leaded through hole components. They are also well suited for mixed assemblies in both commercial as well as military applications. Inorganic acid flux much stronger, corrosive than organic fluxes. Inorganic fluxes are a perfect choice for soldering surfaces that are difficult to bond. They can help get rid of large amounts of oxides from heavily oxidized metals, thus increasing their solderability. Inorganic acid fluxes comprise strong acids, such as hydrochloric acid, ammonium chloride, and zinc chloride. As such, the after-solder residues of these fluxes are very corrosive, and can cause a lot of damage if allowed to remain. Hence, it is important that complete cleaning be performed after the soldering work is done. Applications: inorganic acid fluxes are capable of cleaning strong metals, such as stainless steel, brass, copper, etc. They are typically used in applications such as brazing of copper pipes and lead tinning. Owing to their high corrosiveness, they are not meant to be used in electronic assemblies, such as PCBs, or for electrical work.